Before starting to investigate the reason why the device is not charging the battery, we connect the mobile to a power laboratory supply to check its consumption. When we are making this connection, we observe a consumption of 111 milliamperes, which is not normal for a functional device. A phone must have only a small oscillating consumption as if we were looking for the battery. Therefore, this indicates to us that the device has a problem that prevents it from charging the battery. Let's put into practice what we have learned in this course. We start by briefly analyzing a block diagram, then, to solve a device with problems in the motherboard, we can opt for two methods. The first is to rely on schematics, diagrams, and service manuals, and the second is to rely on our experience and make measurements on the motherboard without the help of the schematics. We start by quickly analyzing a block diagram. In this model, there are two main blocks, the PMIC, voltage manager or main manager, and the EFPMIC or charging circuit. The EFPMIC has to send current to the battery and receive current from the charging port. Between the charging connector and the EFPMIC, there is an OVP, over voltage protection circuit, to provide protection. The EFPMIC also sends a current line called VBAT-SYS directly to the PMIC. This means that the charging integrated circuit or EFPMIC supplies on the one hand the battery and on the other hand the PMIC. This information helps us to determine where to make measurements on the motherboard. Many people open the schematics and they feel fear when they interpreting them, but the reality is different. If we open our eyes a little, we can easily understand them. Instead of working without a specific direction and doing something you don't like, it's better to easily understand the schematic plan. Here we can observe better the important lines of the EFPMIC. We can see lines of humidity detection or water damage device, directional or bidirectional data lines that reach the CPU to activate the cameras, flashes, and similar elements. The lines that only have one arrow are directional, while the lines with two arrows are bidirectional, which means that there is data communication in both directions. The OVP is used to protect the device from overload and short circuits. The OVP circuit limits the charging current to prevent damage to the battery and the device. This big connector is the FPC connector, which connects the baseboard to the main board. This connector passes the charging voltage, which will continue its way through a diode and the U5005, which is an OVP protection. After passing through the OVP, the line leaves it and passes through a capacitor for stabilization, and then it goes directly to a bobbin and at the same time to the integrated circuit charging pad. The other part of the current comes out through this bobbin that has a function for an additional filtering for electromagnetic interferences on the line. Once the current has been established within the EFPMIC, it will be responsible for managing it to the battery with the V-battery line and to the PMIC with the VBAT-SYS line. Understanding a schematic, you can understand the other schematics regardless or whatever you are looking with Xiaomi, Oppo, Huawei or iPhone. Now we can go to the motherboard to make the necessary measurements. First, we will connect the charger and measure the input voltage at the FPC connector that connects the motherboard to the sub-motherboard. We have seen it before in the DZKG tools schematic diagram. In this connector, there must be a charging voltage of around 4.5 volts. So far, everything seems to be in order. Next, we connect the connector to the motherboard and check if a voltage arrives at the battery pin. As we can see, there is no voltage, which means that some circuit is failing, which explains why we had a consumption of 100 milliamperes in the power laboratory supply. Some component is consuming this 100 milliamperes. The device turns on perfectly but does not charge the battery. This is our failure today. In the next step, we'll remove the motherboard from the chassis. Carefully, after removing the screw that holds the motherboard, we'll remove the two coaxial cables. Once the motherboard is out, remove the front camera and the main camera from the device. Don't forget the two protection sponges, we must remove them to avoid heat damage. To hold the motherboard, I'll use this support. I have been using it for 4 or 5 years and so far it has worked well. The next step is to remove the shields. To better understand the process, I will remove some additional shields to see the circuits involved to manage voltage for this device.